There we go. Sweet, look at that. All right, so we're gonna go ahead and get started on this then. And so this first one, we're gonna do, it's called Fleury's algorithm. But the first part just wants us, here's my thing, and it wants us to find a circuit or a path. Okay. It wants us to find if does it have an Euler circuit or an Euler path exists for each graph. If so, identify the start and end and number the edges in order. All right. So where do you want to start on? We'll do this one first. Where do you want to start on this one, Kanaya?
Top left corner.
Top left. So we're going to start right here. So that'll be my start. And then where do you want to go? Just tell me like right, left, up, down.
We can go down.
All right, so down. So we'll call that 1. All right, what do you think next?
Then you can go down again.
Let's do 1, 2.
Then go right.
Go that way. 3.
And then go up. That go up.
Right, 4.
And then go back right.
Okay, 5.
And then you can go down.
6. Then we gotta go 7, 8.
And then
I guess it really doesn't matter, to be honest, because we could do 9, 10, 11, 12, right? 10, 11, 12.
Then go 13. Left. And then the last
you could have also did this, and got to the same spot. So, and then that would be 14. And we got back to our starting point, right? So that would be a circuit. All right. Now what about this one over here? Same thing. Well, let's top left to us right. All right. Which way you want to go? Okay.
You can just go to the right.
Okay. So 1.
Then go over again.
2. Then we gotta go. So go down 3. So we're going.
Then go up.
4. That means that would have to be 5. So now we're here. So maybe this way. 6. Which then we'd have to go 7. We'd have to go 8. We'd have to go 9 or 8.
Wait, you could have went where 7 is. You could have went straight. Oh wait, no.
Because we did 4, 3, up 4, 5, 6, and you would have to go there, right? So we did that 7. So you're saying we could have gone 7. So we could have gone 8, 9, 10, 11. So we would have ended there, right? Which is fine, because this one I think is going to have an Euler path. Okay. This one was a circuit. This one was a path, because my start and my end are 2 different places. All right. So if you remember, and once again, Euler's theorems do identify the existence of an Euler circuit and Euler path. Remember the little rules we talked about the other day? If they were all even, or if they were all, if there's 2 odds or something like that. Then we would have an Euler circuit or path. So Euler's theorems do tell me when I do that they exist, The problem is Euler's theorem do not find a specific Euler circular path. So I can't use, the rule tells me that there is one, but it doesn't tell me where it is, okay? So that's where Fleury's algorithm comes in, all right? And its general idea is don't burn your bridges behind you. So fact number one, an edge can only be traveled once in a path or a circuit. And that's kind of what we did up here. So as you trace edges of a graph, you are limiting the part of the graph left to travel on. And then number two, in the remaining graph left to travel, certain edges you choose may get you stuck and prevent you from tracing all the edges without retracing, which is your bridges. So the concept of a bridge occurs in the yet to be traveled portion of the graph, the remaining graph. All right, so what we're going to do, now we already talked about this. So we're going to tie this into, I'm going to tie it into what we're going to do here. All right, so the first part, so step one, we're going to ask ourselves, does this thing have an Euler path or circuit? And I didn't say hello. Hello, Cameron.
What's up, Mike?
All right. So the first thing we're going to do is we're going to ask ourselves, do we have where's my thing turning? Do we have a circuit or a path? So let's look at this first one. If you have the printout, this is the first one, okay, on the guided notes. So we're going to ask ourselves, is it a circuit or path? And if you remember, one way that we can find out is if we look at all the degrees. So this is degree 2, 1, 2, 3, 4. This is 2, 1, 2, 3, 4. This is 4, 2, 2, 1, 2, 3, 4. And since they're all odd, I know that this should be a circuit no matter what. Okay? Because if you go back to what we learned the other day, and they kind of do it here, if the graph's connected and has no odd vertices, we have a circuit. And since they were all even. Now, choose any vertex unless given a specific one to start with. For an Euler circuit, any vertex can be the start and the end of the circuit. So in this case, it really does not matter. We could choose any one that we want to. So let's just say we're going to start with A. All right, it'll be my start. And then what it says to do, label or indicate the edge you have already traveled by numbering them in order. In the remaining graph, first, always choose an unused edge that is not a bridge. Remember, we talked about a bridge the other day is one of those, like if you took it out, there would be no other ways to go. Finally, only choose a bridge if and only if the only option at your current vertex. So we're going to kind of work our way around and just make sure that we always just don't choose a bridge. So we could go 1, because I could still get to B another way. So that's not a bridge. All right. Let's just do 2. Then we can do 3. All right. Now, once again, I could choose this one because this is not a bridge, because I could get to G going around if I needed to. So that technically makes this not a bridge. 4. Now that I kind of have to go this way. 5, 6. All right, now here I could do 7. And then we could do 8, 9, and then up to the end, and that got us back around to our start. So I knew it was a circuit, and there we go. All right, now let's look at example 2 for a second. So same thing. Let's use our little Fleury's algorithm. So step number 1, remember, we just need to figure out, well, what is this same thing going to have? Okay, is it going to have a path or is it going to have a circuit? And so on this one, well, that would be a 2. That's a 3. So right there, I know it's not a circuit. That's 2. 1, 2, 3. That's a 4. That's 2. That's a 1. This is a 2. And that's a 2. So because it has only 2 odd ones, then I know this is going to have a path. All right. Now, if you go down to Fleury's algorithm with a path, it says we have to choose either of the odd vertices for our starting point. So if we're going to make this work, if it's got a path, we have to start at one of the odd ones. Okay. So where would you want to start on this one? I would start at C. And the reason I say C, because if we end up getting there, we're not going to be able to travel backwards to get out of it. So that either has to be our starting point, or it would have to be our very last point. It would have to be our ending point. All right. So then if I want to do my path, then I would do 1, because I kind of have to, 2, and then which way you want to go? Let's do 3, 4, 5, then this could be 6, 7, 8, and 9. And if you notice, we'll end up back at our odd one. So this one, my circuit is going to end at D. Okay. All right. So let's do this then. And if we get these right, then I'll let you be. Kanaya, I want you to do number 3. And Cameron, I want you to do number 4. Now you can look at them for a minute. Okay.